So hello and welcome to designTimber. My name is Tabitha Binding. I'm Head of Education Engagement for Timber Development UK. And this is the second series from Timber Development UK, where we're creating the opportunity to learn directly from the multidisciplinary teams behind incredible projects selected from the Wood Awards 2022. The future of the timber industry is upon us, and Timber Development UK has been formed from the merger of two of the largest and longest established organisations in the supply chain, the Timber Trade Federation and the Timber Research and Development Association, formerly known as TRADA. We're seeking to connect the supply chain, lead best practice and accelerate a low carbon future. And to do that, we've completely designed the website with lots of more exciting features, lots of great case studies, and you'll find one on today's talk. The Wood Awards, again, will be heavily featured, and Bryony, my co-host today, is heavily involved in that. And we also have two new design magazines. So if you've got any articles or any events, please get in touch and we'll help you promote them, because we're all here to understand more about timber and use it wisely and well. So today we're going to hear from the team behind Homerton College Dining Hall. Eleanor Hedley from Feilden Fowles, who's an architect, Sophie Frith from Structure Workshop, who's an engineer, and Paul Tracey, our timber construction specialist. And with that, I'm going to stop sharing and hand over to Eleanor. If you've got any questions at all, please put them into the chat and we'll come to that at the end of the presentations. Eleanor, it's all yours if you're able to share.
Yeah, thank you very much for the introduction. I will just share my screen of our slides. Please let me know if there's any issues as we go. But yes, wonderful. Introducing the new dining hall at Homerton College. So this was a project completed nearly a year ago now in Cambridge. As a bit of context, so this is a project that we're really proud to have worked with Structure Workshop on. At Feilden Fowles, we've worked with Structure Workshop on a number of buildings. This is just a few of them on screen now. One of them is the building I'm in today, which is our own studio. So designing timber frames alongside Structure Workshop is something that we've had history in, and the Homerton project was a really nice evolution of that work. So this is the completed building. I will, throughout my presentation, I'll talk a little bit about the other materials that you can see externally here, the concrete and faience, but mostly I will brush past those and then introduce you to Sophie to talk more about the technical side of the timber frame. So the college itself is one of the more modern Cambridge colleges. It's located to the south of the city centre, and the advantage of that is that it actually has much more space available to develop than a lot of the inner city colleges, which are much tighter sites. So if anyone's familiar with Cambridge, you exit the train station travelling south down Hills Road. Harrison Drive branches off that. The main entrance to the college is off Hills Road. Harrison Drive is more of a back road, and the main college building sort of exists along the northern side along that street. This here was our site for the new dining hall. This was the site as we came to it. This is a useful image to introduce our neighbour to the project. So in the centre here is the Ibison building, which is the college's only listed building. It has arts and crafts detailing to it, which I'll come to later was a really key kind of touch point for the design development. And then these single story buildings to the side here were actually removed to make way for the project. So this is the college's existing dining hall, which is very much in line with the kind of tradition and what you kind of picture a Cambridge dining hall looking like. I think sort of the dark hammer beam timber roof, rows of tables, quite ornate. And unfortunately for the college, they've grown beyond capacity for this hall. They can no longer fit a single year group in. So that was sort of one of the leading design factors in order to sort of trigger the new project, alongside the fact that their existing kitchens and servery, pictured here, were very tight, not really serving the number of students that are coming through every day, not allowing them to produce the food at the quality that they wanted to, and also not a very nice working environment, very little natural light. So that kind of sums up twofold what the brief was. It's sort of looking back to that, the kind of tradition of a Cambridge dining hall that I touched upon kind of comes from the history of sort of large manor houses and the halls that they would have had. And historically, there would be this passage, screens passage, that would connect the dining hall with the kitchen, buttery and pantry, and that would be the main circulation. You'd have a raised dais at one end, an oriel window, and historically they would often have a hearth centrally, which is obviously gone now, but that's often the reason why there's a spire or some sort of projection in the roof, so you might see that when you look at other historic halls. The college's existing dining hall has it. I think I showed it on this slide here, the flesh there, and that actually inspired some of the forms we took in the new dining hall. So the brief, as I say, the main two key points of the brief were the hall itself and the kitchens. So they were the two large masses in plan, and they'd be connected by the servery space where you take your tray and collect your lunch, and a large adjacent gathering space that connected them all together. As well as being very sort of celebratory a space, the hall also had to be very functional. The connection to the kitchen, the flow of food in and out. It had to work in the day for lunch service, it has to work in the evening for more formal sort of dinners. And this sort of crystallized, so this from this early sketch into this plan where you can see that the two main footprints are the kitchen at the back there, accessed off the road, and the dining hall, which addresses the college's grounds. And then there's the gathering space, which became known as the buttery, which has a little cafe counter, and that's become a really successful study space, which I'll show you some photos of to come. This is the first floor plan. This is a balcony around that buttery space, and a balcony that overlooks the hall. And again, that's sort of using traditional motifs from the Cambridge dining halls. They often will have a little raised space. So in order to first sort of make our design response sit well in context, we looked around at the college's existing buildings. And here you can see the sort of arts and crafts details of the Ibison building I mentioned before, the tones of the brick, flint work, and also influencing the planting and the landscape design surrounding the building. And so this is also looking to roof lines around the college, because the new building, I don't think I've shown an image yet of the gable end, but has a quite striking form, a valley roof. So looking at existing pictures, etc., around the college, also looking at existing colonnade sort of rhythms around the college that influenced our ground floor plan, which was very much weighted by this concrete base. And we started to develop the idea of the concrete base and with two projecting volumes. So this is where the timber starts to come in. So these projecting volumes, we always wanted to announce the hall itself and the gathering space with sort of these projecting boxes that you can see on the new plan in its location, these two dark areas. So the new hall, its front line aligning with the Great Hall that's further along in the grounds here. And then that started to develop, so these two projecting boxes on a heavy base started to develop our material language. So apologies, this is quite pale, but this is a really crucial drawing. It's an early drawing, so things have moved on a little bit in the actual delivered plan, but you can see how the structured sort of concrete and brick base at ground floor on a really tight 3-meter grid, very restrained, and then the timber boxes lower down onto that, give you the height, give you the celebratory space and lightness. And then the cladding that goes onto that is faience, which I'll show you some images of to come, and led to an interesting kind of structural hybrid response we've worked on with Structure Workshop. This was an early visual looking across the college, and you can see those two spaces that I spoke about, so the kind of gathering study space and the hall itself. And you can start to see, this is a competition image, I think, you can start to see the the way that the faience is starting to taper as you get up to the top of the building, and at night the tapering allows for the clerestory glazing between the ribs to sort of create a lantern and a sort of glow of the hall across the campus. In terms of how we developed the design, a lot of sketching that you've already seen. We also worked on quite large scale models to really get into these interiors, tiny furniture, tiny portraits, tiny lights. But also it was really important in developing the linings and the scale of the spaces. So you can see the hall and the buttery that I've been talking about start to come to life. And these were really really useful design tools for us. So some of the images are also really nice because when you have the real life picture of the model image side by side, it's a really nice pair. So these are still the models. And this is one of the final model images of the hall itself. So talking a bit about materials. So I wanted to talk slightly about the concrete and the faience as the other two key materials before handing you to Sophie to hear more about the timber frame. So broadly, this was our material palette. We have a base, a colonnade grid of in situ concrete. We use pigmented concrete with 50% GGBS content in order to create this, the pink tone that you see inside and out. Complementary brick, colour inspired by the existing college, mostly the Ibison building adjacent. The lovely timber frame, glazing, and the faience. So that's sort of colour coded throughout these two plans on the left. So to talk a bit about the concrete, I'll just flick you through quite quickly some of the construction images, because there's sort of, well, firstly, I find them quite fascinating, but also I think if we're talking timber, there's some fantastic joinery went into the formwork, because we wanted to have a board marked finish on our concrete columns. And I can't remember the exact prices, but I know that some of our curved concrete formwork for the columns were very expensive and like pieces of art in themselves somehow. Reused, brushed down between uses, and it adds a lot to the outside to have that timber texture. So this is one of the columns as the formwork is being removed, and this is the completed base of building of the hall. And then to talk briefly about the faience, which clads the exterior of the hall. This is actually an inspiration image. It's actually the base of a pub on King's Cross Road, which is not the most glamorous beginnings, but if you look closely, it's incredibly beautiful. And you see this around, quite a few pubs have faience bases. It's incredibly hard wear and easily cleaned material, and this one is especially beautiful. They're not all this beautiful, but this material, once you spot it, you start seeing it everywhere, tube station entrances, etc. And in terms of our use of it, we were, let's say, looking at cladding the hall, but also creating this tapering form inspired by that spire on the existing dining hall. And we looked at a few different structural solutions with Structure Workshop, initially approaching the faience cladding as a series of tiles that were hung off a steel frame. But then that stopped making sense by the time you've got concrete, you've got timber and steel and this material that has the capacity to be load bearing. It didn't make sense. So Structure Workshop helped us pare it right back, and the faience ended up being load bearing itself and formed from these pots. So this is part of the glazing process. This was done by a company called Darwin Terracotta. We were very patient with us, lots of different samples of how to get the finish we were after. This is the install, and then the final impact here. So some shots of the exterior of the building before I move inside. I really love the shadows that the curves create in this one. I think I'm really pleased with how that came out. So this is that gable end of the hall that starts to show where that butterfly truss impacts the external form of the building. A few more external shots, and then I'll take you inside. This is inside that buttery space, looking out. We've got quite a lot of internal joinery, ash being the predominant material used here, so stairs, balustrades, handrails, and also wall linings. These were done by a company called Classic Bar, who were fantastic to work with. They They were the kind of company who prefer to do you a mock-up than actually do a drawing. It's just quicker, and you get a sort of quicker response, and they're really kind of, the design process was really enjoyable with them. So this is the buttery, which is always full whenever we go, which is really lovely to see. Really successful space with the students. And then moving to the hall itself. So here is where the real kind of exciting timber structure comes in, as well as these ash linings which are corrugated, and that corrugation is influenced by the linen fold panelling you can see elsewhere in the building. We've got a dark stain to our timbers at ground level, and then we allow the ash sort of colour to show through higher levels. We use the ash because of its sort of lively grain, and it's the colours with the timber used for the structure kind of complementary, and it sort of all hangs together in that sense. So I will, off the back of this image and that amazing light coming through, which I just love, I will hand you over to Sophie to tell you more about the timber frame itself.
Brilliant, thank you, Eleanor. And just to remind our participants, if you've got any questions, please pop them in the chat and we'll come to you at the end. It's full screen, Sophie.
Is that okay? Brilliant. Thanks, Eleanor. That was a great introduction to the project, and Tabitha and TD UK for letting us speak about the project very briefly. It was quite difficult to figure out what I wanted to say, actually, because there's so much to the project and so much about the timber, but I've only got a limited amount of time. So I'm going to try and talk about the timber selection and then how that fed into the design of the butterfly truss in particular. I thought I'd focus mainly on the butterfly truss because it's the most interesting from an engineering point of view. The other timber spaces are interesting, but it's, you know, a series of primary beams, which is less interesting. And then quickly talk about the approach to the connection design, some amazing photos from the fabrication at Constructional Timber, and then some key takeaways of mine from my experience of working on the project. So the timber selection, this was really where it all began. As Eleanor was saying, the timber was being used to create these celebratory spaces. So the buttery, the gathering space, and the dining hall, they needed to be really special. So what was the timber going to actually be? It needed to be long enough to span the 12-meter span of the buttery and the 15-meter span of the dining hall. It also needed to be beautiful but economic, and it needed to have the correct material properties. So in the early stages, we thought a lot about this and ruled out solid softwood or hardwood timber because of problems with available cross-section sizes and lengths. So that led us into different engineering products such as basic spruce glulam to more bespoke high-end oak glulam, some LVLs, baubuka. And it was through collaboration with the QS and the architect and the client that we settled on a sweet chestnut. And this was a combination of strength, visual appearance, economy. And one of the things that we found particularly special about it was that the sweet chestnut's actually coppiced. So the harvest, it's harvested without killing the root. So there's environmental benefits without having to clear fell the forests. And so even though you've got small trunks, you get these thin laths, which, although they're very thin, can be laminated to make a really high performing glue laminated timber. And we actually went to a company called Inward Developments to see some homegrown sweet chestnut being made. You can see on the left, there's some 22mm thick laths stacked up, ready to be laminated. And then on the right, there's me next to that press looking suitably excited. So yeah, once we decided on what the timber was going to be, we could then start thinking about how it was going to be used. and particularly how it was going to be used to assemble the dining hall trusses. One of the key questions with the dining hall truss was how it was going to be divided into parts. And once we knew there was going to be sweet chestnut, we knew what the available lengths were going to be, we could see how we were going to divide up this truss. And this was critical because the continuity of the members affected both the buildability, but also dictated how the stresses, how the forces were going to be distributed into the members, and then the resulting deflections and everything like that. And so for the sweet chestnut, it was the maximum available length was about 13.5 meters. So it meant that we could achieve that in the columns, but we couldn't achieve it in the diagonal members because they were about 15.2 meters. So we ended up going for the top middle section that's shown on the screen, where the columns are continuous and then all the 4 diagonal members are discrete. And so structurally, this behaves a little bit like a 3-pinned arch. It's statically determinate, but it's not very, it doesn't perform very well because you don't tie the eaves together at the base of the struts. There's a lot of spread, so you get this sort of action. Apologies for the crudeness of these diagrams, but hopefully yeah, they show it quite well. So when we looked at the truss like this, the columns were having to get quite deep to resist this thrust from the struts. And so, yeah, to keep stresses low and keep deflections low, they had to get quite deep, which wasn't preferable architecturally, but also it wasn't really using the timber in the best way. And so we wanted to think of another solution. And jumping back to the plan very briefly, there was an opportunity to resist this thrust with the concrete that surrounded it. So the concrete structure, as Eleanor was saying, was supporting this big mass of load-bearing faience. And, you know, it was a very heavy, very stiff structure, and it would be a shame to ignore that benefit. And so we decided to prop the truss with the external concrete. And so you can see here, by providing that restraint at the base, pretty much at the base of the struts, you get this really stable node at the central joint, which is essentially just a stiff point in space. And then your upper members can just come and sit on top and act primarily in bending to span between that central joint and the top of the columns. And more diagrams, apologies. The vertical load from the roof is transferred to the top of the column and the central node, and then the columns and the struts just act in compression. And then the concrete foundations and the concrete columns resist these forces. And what's quite interesting is how this bears a comparison to the naves of churches and cathedrals. So this is just superimposed not to scale Homerton onto Durham Cathedral, and you can see how it's similar. The vault, the stone vault of Durham Cathedral, has the same thrusting action that needs to be resisted, and here it's resisted by the flying buttresses, but in Homerton it's resisted by the concrete structure, which is not as deep as a flying buttress, but because it's reinforced, you know, has good bending stiffness. And yeah, I think this diagram is just really nice to show how the timber, although the frame, it's not, you don't see it very often, it's a similar, it's taking themes from traditional construction and just giving it a bit of a funky twist. And very briefly, obviously, vertical load wasn't the only thing at play. We also had to deal with wind. Luckily, we had this really stiff facade, which dealt with most of the face loads and the timber had to do very little with resisting the wind. It had uplift on the roof, which would essentially just reverse the forces that I was talking about previously, but the truss never went into load reversal. So moving on. So the approach to the connections. At stage 2, we were exploring every option really. So this was just a snippet from our stage 2 report that showed looking at resin fixings, looking at cast nodes, flitch plates, all of the above. And it was through collaboration with the architects and as Eleanor said, taking inspiration from the arts and crafts movement, that the idea of carpentry connections came about, and thinking back to the similarities with the cathedrals and having this modern take on traditional construction, the idea of using carpentry connections was really compelling, and one that we took forward and really, you know, just hit the ground running on in stage 3. And so what did that mean? The most difficult connection to design was definitely the central joint. As I was saying before, we had these 4 members all coming into a central node, and we couldn't find any examples of anything being done like this. So it began with sketching and then continued through to model making. And this was the first foam model that we did with a hot wire cutter, first stab at what this connection should look like. And it's really amazing what you can learn from making these models. This one, for example, we realized that there's 6 exposed mating faces on both sides, and getting those joints perfect to look neat, it was very, very difficult. So we knew that we needed a series of simplifications. So the next, this is the joint that we ended up with. This is a model that Peter made at Structure Workshop, which has slightly different fixing arrangement, but as principles, this is what it ended up being. And through, obviously, to go alongside the model making, we had to do calculations. It's a very boring slide, but yeah, I think it's quite uncommon for engineers to design a carpentry connection, but really the calculations are very simple. Everything's just acting in compression. So it's a series of checks for compression perpendicular to the grain or parallel to the grain or at an angle to the grain. What was quite interesting and surprising to some was throughout stages 2 to 5, really, we were taking the mechanical properties of the sweet chestnut using a Eurocode, which essentially gave the strength properties of hardwood glue-lams. And it wasn't until stage 5 that we knew where the timber was coming from, a manufacturer called Sierra Lam, and we got their published data for the mechanical properties, and these varied quite significantly to what we'd assumed in our calculations, especially the compressive strength perpendicular to the grain, which was key in the calculations of the connections. So the connection design had to be checked in stage 5, which was quite stressful, but it was all fine in the end. And yeah, so the design remained the same, luckily. Not all the connections were as glamorous. I just thought I would touch on this one because this was the restraint back to the concrete structure, which was so critical in making the truss as elegant as it is. You can't see it. And so this was important because we wanted it to provide a lot of tolerance in 3 directions. So not only did it need to provide tolerance vertically and horizontally in plan, but also, you know, to account for any deviations in the concrete frame. So I think we provided around 30 mil tolerance through a series of vertically slotted holes, horizontally slotted holes, and space for packers. Despite designing this in, it didn't all go to plan, and the cast-in brackets into the concrete were far off what we wanted them to be, and so we had to get specially fabricated brackets for the timber, which was a bit of a shame, and it's definitely one of our key takeaways, that you can never design in enough tolerance into your designs. So now I'm just going to steal Paul from Constructional Timber's thunder by showing some photos from fabrication. So this is their workshop in Barnsley, and you can see that the Homerton really took over their entire workshop. And despite them getting a really nice new CNC machine, most of the work was done by hand, you know, chiseling away. And each of the trusses was test assembled on the floor, and each of the members, I believe, Paul might correct me later, each of the members was given a unique identity to the truss. So an upper rafter belonged to a truss, and so each of the trusses were checked before going to site to make sure that there were no, you know, disasters. And, you know, it's just a nice picture, man with a big hammer. The fit was so good. You just need a bit of force to get it in and out. This is, I didn't touch on the base connection earlier, but I thought I'd share this picture because, again, thinking back to the available length, the columns were just a little bit too tall to be sourced in the sweet chestnut, and so we had to provide these quite tall steel plinths, and that provided a durability benefit as well by taking it off the ground. But we were the architect wanted a very nice flush finish around the base of the column, so we notched the column into steel shoe, and it's just quite amazing to see how thin the timber can become. So you can see that the timber actually extends within this shoe, and you can see the three little countersunk screws there. It extends just below there, and that's just because of the high compressive strength properties of this glue lamp. That I think the cross section went down to something like 90 by 100, and it's supporting this 15-meter long roof. It's really quite incredible, and the resulting detail of the foot it's really beautiful. Buildability was always in our minds, and we produced this construction sequence drawing for Tender. Sorry, it's very pixelated, but the idea is that we envisage the concrete frame being up first, then we install the timber columns, the lower struts go on, the upper rafters go on, the CLT deck goes in, the wind posts go in, the windows go in, and the faience goes in, and it pretty much all went to plan like that, amazingly. So this is an interior view of the hall where when there's no timbers, just concrete. This is a shot where the column has been installed, and you can see that restraint detail back to the concrete. You'll notice that it's not perfectly in line with the strut, so there is still bending going into the columns, but definitely not as much as if we didn't have the restraints at all. Yeah, these are the two struts going in at the central node. This is all of the trusses with their two bottom members ready to receive the top rafters. This is a shot of the central joint and then drilling through the tenons. So what Constructional Timber did was pre-drilled the holes for the pegs on the mortise, but didn't on the tenons to account for any tolerance. So they had the holes set out nicely in the mortise, and then they drilled the rest on site. And then this is a shot of the eaves. And just a quick mention about the CLT, which I've not talked about. So the dining hall had a CLT deck on it, which supported all the ceiling finishes and the roof coverings. And it also provided a restraint to the head of the windows, and the faience fins as well. And I think this was really successful. One of the one of the things that people point out is that there's no eaves beam, and having this CLT there to provide a really thin build-up makes the eaves detail really special and very unique. So yeah, it was just some finish shots of the building next to our construction drawings. I just thought I'd show these because it was really nice to see our construction drawings actually come to life. So this is the bridle joint, and this is the central joint and the heel joint in all their glory. And so yeah, our key takeaways, quite obviously, understanding available timber sizes in terms of the cross-section and available lengths and different species and different engineered timber types is really critical. Integrating the approach to connections in the early design stages. It's very easy as engineers just to think, oh, let's just use steel bolts, but you're missing out on, a plethora of opportunities if you just default to that. Be aware that design codes are not always reflective of timber products on the market. Like I was saying, I used a Eurocode method of calculating mechanical properties, which varied very differently to the product on the market. So that's the one thing to be aware of. Collaborate with and learn from carpenters. I mean, Paul and Constructional Timber's expertise was second to none, and we wouldn't have been able to get through the project without them. So that was really key. Build mock-ups during design if they're useful. They were really useful for us to think about buildability and for proof of concept. And design in more tolerance than you think you need, especially when you're mixing materials. When you've got timber against steel against concrete, they all have different setting out tolerances, material tolerances, geometric tolerances. So yeah, always think about tolerance. And I think that is everything I have to say.
Thank you, Sophie. That was, well, both of you. Absolutely amazing. So again, going back to our audience, if you've got any questions, please put them in the chat and we will come to answer them. And Bryony is my colleague in the background. She's just highlighting us all so that you get to see all of us at once. And Paul, how did you come to, and excuse my how did you enjoy working with this fantastic team of women, and obviously all behind the scenes as well?
Yeah, well, it was good to get involved early on, as Sophie said. We were kind of brought in as a specialist after they'd looked at some sort of UK option, should we say, of making the beams. But obviously you needed the span and you needed the strength. The good thing about the supply we used is that they GL grade the hardwood, so they GL grade the sweet chestnut to GL30C, and obviously provided Sophie with relevant technical information for her to be able to design the structure based on their particular sweet chestnut. Normally with hardwood glulams, you don't get a GL grade. You get some technical specifications and some information, but I think it's more difficult to be 100% certain of what you're actually going to get. Whereas with Sierra Lamb, they provided some good technical backup for us. And then it's from our point of view, obviously, yeah, we've got a big CNC machine. We do a lot of stuff using the machine, but it was also nice to go back to traditional carpentry. It's a lot of hard work for the guys downstairs, but also I think they get a lot out of it when they see the finished product on site, and also they got to put each one of those trusses together, so they did get to see it. And then, as Sophie said, they were all individually done, and then we wrapped them all as a pack, so that only one rafter could go with each post, and etc. So yeah, each truss is in theory identical, but actually everyone's just slightly different.
A bit like people, we're all people,
yeah.
But yeah. So when were you invited in to the in stages? Which sort of the Reba stages did you come in?
I think we were stage 3 from memory when we're talking to Barnes Construction, obviously the main contractor. There were lots of different species kind of being spoken about. We came down, I think, to a meeting. I think I met Eleanor and Sophie there, and obviously the QS. representative for the college, obviously, was very keen to know about how much all these options cost, which is another consideration when you're looking into which timber to use. So yeah, when we obviously made contact with Sierra Land. They were a new supplier to us, but they were very keen to get involved in the UK. So they offered us a lot of assistance and technical support. And then obviously when I brought some samples down, it was decided which particular species we were going to go for. And then from then, obviously, we were able to then back that up with technical information from the manufacturer and assist Sophie with what's achievable. Because the other big thing with the connections is what can you actually machine, and what, you know, obviously the Hundegger, the CNC machine has got specific parameters. So it was a bit of a combination between some machine work and some carpentry work. So with that in mind, we kind of went through, our draftsman went through with Sophie what was achievable, what wasn't achievable. And then that kind of dictated how we ended up with the exact central connection that we got in the finished product.
I love the thinking, you know, about how you're going to construct it on site, and actually, yeah, even with the mortise and tenon, only drilling the holes on the outside, so then you can slide them in on the inside. And I saw the lovely shot of trying to hold the water back, you know, with that beautiful like internal gutter. I was just like, you know, I get a bit worried about flat roofs, but internal gutters, you know, but you did it.
Yeah, the installation went pretty well. Like I said, as Sophie said, you know, you always take things away. Whenever you connect into anything that's concrete, their tolerances are way outside anything that we can work to. Generally, ours are plus or minus 2 mil. They can work up to anything 30, 40 mil. I think there's Ancon brackets that Sophie was talking about. According to the person who cast them in, we're all within tolerance, but some of them were nowhere near where we needed it to be. So as we said, the easiest thing was we were able to go and fabricate individual brackets to connect each column to the Ancon cast-in fixing.
Yeah. No, thank you, Paul. So Eleanor, where did you bring you know, structure and Sophie into the project? Was it right from the beginning, or?
I remember during the competition stage, I mean, our brief was how can we, I mean, we always knew we had to have a large span of an open area without columns in it. So that was the absolute baseline of the brief. And then it was like how to do that in an expressive way that creates drama, that has you looking up, that plays with that south light as it moves round. So, and I think, I mean, we had those discussions with Structure Workshop from very early. So we have history of working with them. We know how creative they are. So they're really good partners in that process. It's never, they'd never turn around and sort of say that things are impossible or need to be massive sections or any of that. So it was a good collaboration on that front, and I think sort of mutual creativity, I suppose. I mean, throughout the design sort of competition, the distant memories of the late nights of competition, we sketched absolutely every truss under the sun, but we didn't want it to be too, I mean, I say we sketched every truss. I mean, we're architects, we sketched every kind of completely ridiculous, unperforming, nonsensical truss, probably. We're not engineers. We just wanted it to look good. But we also, I mean, we used that hammer beam idea as a starting point, and we knew that, you know, that was the sort of historical way of achieving these large spans, but how do we create a new version of, one phrase that we kept referring back to was the idea of arts and crafts for the 21st century. So you can see, and I think that the timber represents that, as Paul said, the combination of the digital and the handmade. And you can see that in the faience and how that came out, and the concrete as well. You know, handmade formwork, handmade, hand applied glazes, that sort of thing. So we're up for embracing the inconsistency sometimes in handmade materials, although that's not the case with the timber frame, very much was with the finishes of the sort of more of the cast materials. Yeah.
That's it. I love the interaction, as you said, the craftsmanship of it. Definitely feels like, you know, like William Morris appreciating the beauty of every single material, and then bringing it forward and enhancing it, and minimizing the usage of it, you know, through then that clever designs. But Sophie, so where did you come? You know, where do you remember coming into it, and had you actually ever really designed much in timber before? Because timber's not particularly taught well in universities in the UK.
What a good question. I was a much younger woman when I started working, so I don't remember much. But I mean, as Eleanor said, it was such an amazing design process to go through at the start. It was very, very collaborative, and we all just our motivation was to create an amazing dining hall, and we all wanted the timber structure to be as beautiful as possible, and people have described it as daringly slender, so I think we did a very good job. In terms of designing timber itself, Structure Workshop, the company I work for that worked on the project, we have a pretty good specialty in timber design, I like to say. So it wasn't, it wasn't virgin to me, but in terms of the carpentry connections, looking at that was completely novel, and it was a great process to go through. And again, just understanding the different engineered timbers. I'd never thought of using a hardwood glulam before, and yeah, looking at the differences of oak and sweet chestnut and understanding the benefits and disadvantages of both of those was really interesting. So yeah, it taught a lot. It was a really great design process.
It does. It seems amazing, and I know we've got the questions, sort of starting to flood in. But,
it is very poorly taught in university, though. Just to go back to that, for some reason they don't like to teach us about timber in university.
So I think the Joint Wood Award moderators is changing that now with sustainability and bringing in other materials. So timber will no longer be an other material along with masonry and glass, but we'll start to balance it. I suppose climate crisis and looking at carbon and embodied carbon obviously will highly start to influence designs, and we are looking to see it better taught. But Eleanor, did you also do anything much with timber in university when you studied?
When I studied, not specifically. No, I suppose when you're in architecture school, your projects end up quite sort of personal and specific and sort of often program or site led. But personally, no, it wasn't something I had sort of encountered while studying. But similar to Sophie, I work at a practice where it's a specialism. It's something we love to work with, and we built up our expertise pretty much alongside Structure Workshop in the studio building which I'm currently in, the Feilden Fowles studio, which is in Waterloo, which is on the Waterloo City Farm, where we actually built 3 structures with Structure Workshop's input. So we built animal pens as our first part of the farm design, and that was sort of timber, rough sawn timber, double columns, and then we evolved that frame to create the barn, which is at the far end of our site. There was an image of it on my early slide, and then the final timber frame on this site is the studio I'm sat in. So they were kind of all evolutions of each other, all learning points, all share similarities, and a sort of concept of demountability as well. So we were used to working with Structure Workshop on individual joints, mechanical fixings, that sort of thing. And actually, it was a really wonderful moment. The Homerton client, during the competition, the final stages, they wanted to visit practices in person, so they came to the studio. And so we, I feel like I can't really show you that well in this context, but we basically have a mono-pitch roof. And so we were saying to the client at the time, imagine this space, because it's roughly half the span, imagine this space mirrored, and that's sort of the feel and space we want to create for your dining hall. So it was really lovely to be able to bring them to a project we'd done that sort of could evoke kind of nearly one-to-one of what we were proposing for them. So yeah, as a practice, we've also gone on to work with timber frames in sort of other projects, Yorkshire Sculpture Park, etc., Western there. So yeah, it's become a real sort of enthusiasm, definitely, in the sort of low tech qualities of it. Yeah.
No, that's brilliant. As you carry on, it's always that continual learning. And Paul, I'm just going to come to you. But I think there was actually a case study on the now the TD UK website of your actual office as well as the Homerton Hall building. How did you get involved in timber, Paul? What is your background to bringing into it, and how do you feel about working with architects and engineers?
Well, it's like you say, we tend to deal with the specialists in terms of people who've dealt with timber before. The Structure Workshop, I think we'd touched on a few jobs with them before, and we've done some work with them since. And same with architecture at Factory. You tend to get involved with the same practices because they tend to be specialising in timber. So in that respect, obviously, I think we've done some work with Feilden Fowles before, looking at a few of the jobs. So yeah, tends to be the same people who kind of come around, looking at interesting projects, especially if you've built a good relationship with the design team on a certain job. They know what's achievable from our point of view, what we can do here at our base in Barnsley, and then that feeds through obviously to other jobs, because we don't tend, all our jobs are one-off, so we don't tend to do sort of domestic housing or anything of that nature in terms of sort of panels and things like that. It's more the bespoke one-off kind of construction.
Yeah, that is true. It's very different, isn't it? Whether you're coming in at residential or, as you said, bespoke one-off. Fantastic opportunity to work on a building like this at Homerton. I'm going to go to question and answers. I'd invite you to all keep your probably microphones on, unless it's noisy in the background, Eleanor, and all your colleagues are getting raucous. It's probably just easier to stick your hand off if you want to actually sort of answer it, and we'll just try and get through as many as we can, because again, just this fabulous knowledge from you all. I'm going to work from the top down. So since you're using glulam, why not just use long beams and a simple cross lap joint in the crossing? Who wants to go with that?
I guess I'll take that one. Well, as I mentioned earlier, that the diagonal was 15.2, and in terms of what can be transported to site and what was available on the market, that did seem a bit too long. And so we did think about one of our early sketches was just a long spanning beam they buttered up, or they had a half lap, or you doubled up one and there was a single. We had a look at a lot of those different options, but yeah, I think it was the availability of the length that was the problem. I mean, we did look at the proportions of the hall, changed quite a few times to try and make it work for the availability of timber. So yeah, it was constraints with what was available on the market. But then also, I think the finished product is very special. And if it was just two beams side by side with some bolts through, it wouldn't be as amazing.
Yeah, I was going to say that's why you need to engage obviously with a specialist and their supply chain, because like I said, this is our first sweet chestnut job in the UK. If they'd have picked one of the other species, like a European larch, or if we'd have gone for the spruce, then it could have been whatever length was required. I remember sitting down to the first meeting, I think the column was 13.65 meters or something like that. And immediately I got onto the supplier in Spain and they were like, we can't make that. It's got a maximum length of 13.5 meters. These are the dimensions, maximum dimensions of the beams. And then that's obviously fed to Sophie to say, right, this is the biggest beam they can make. You have to obviously make the design work to those parameters. So it's all about getting early engagement of supply chain and who can supply, what size beams.
Oh, brilliant. And I love the shoe joint. Do you know, I know I was thinking it's probably a bit irreverent. It was like this building's actually in high heels, these glass high heels, so it's, I won't forget that now. How is the frame braced in the plane going down the length of the hall?
Good question. So the concrete that surrounds the hall pretty much provides the stability for the hall, and so there's concrete moment frames along longitudinally, and then the CLT deck also acts as a diaphragm as well. So yeah, essentially there's barely any wind or horizontal pressures on the timber frame at all, because we've got this solid facade that's got this concrete subframe that essentially just protects the timber from anything. But yeah, the head of the trusses is supported by this CLT deck, which is connected to the concrete at the gable ends to ensure stability.
Brilliant, thanks, Sophie. I say this is an interesting one for me because I know the answer to it, but how did you overcome the risk of corrosion and reaction between sweet chestnut and steel fixing? So somebody knows their timber here.
Yeah, I think, well, I think that's sometimes a bit of a fallacy regards hardwoods, and I presume this is referring to stainless steel or galvanized. With engineered timber, because all the laminates are kiln dried before they're pressed to form the beam, there is really no issue with using a laminated hardwood and galvanized metalwork. It can be the same also for solid section timber if it in the permanent state is not going to be exposed to direct wetting. So in general sense, even if you use an engineered timber hardwoods outside, so laminated oak, laminated sweet chestnut, or if you're using solid section oak outside, then we'd always recommend using stainless steel fixings and metalwork. But with an engineered timber, especially if it's internal, we've never seen any evidence of any kind of corrosion between galvanized steelwork and oak glulam or chestnut glulam.
Yeah, you touched on the points, whether it's internal or external, and again, how you've dealt with moisture and the fact it is already been kiln dried down to where hopefully it will sit within that structure and you won't get much variations in the humidity in there, which actually comes to another question from, it's a lovely clean ceiling, no services on show. How is the space heating, cooling and ventilated?
I'll take that one. So it's heated through underfloor, under the cat under the terrazzo floor, and it's ventilated partly passively. There's some high level vents on the northern side, and then on the southern side, low level doors that open directly to outside. But also because of its nature of sort of high capacity hall where large numbers of people enter in one go, and so need for a sort of slightly quicker reacting system, as well as the passive system. It's backed up by an HVAC system, and air enters through slits in the ash paneling on the northern elevation. So it's a bit of a hybrid in that sense.
No, thank you for that. And one final question. We're running out of time. There's lots of questions, so I don't know if we can pass them on to you and you'll have the time to answer them, but we'll work with you and see that. A valley roof over a timber frame is an interesting decision from a durability perspective. How was that dealt with? Paul's laughing. And so is Eleanor.
There was a lot of talk about that gutter, wasn't there, Sophie?
There was a lot of talk about it, and they're very sophisticated and hopefully seamless siphonic drain is in place, which is keeping the timber dry. I mean, one of the good things about the glulam is that it's all on show, and so if there are any moisture issues, you'll be able to see it. And in the temporary case during construction, if it did get wet, then, you know, once the roof finishes were on and it was watertight, it could dry out. The biggest problem, like you were saying earlier, Tabitha, is, you know, it's CLT on a flat roof is dangerous. In a valley, even more so. and it, yeah, I mean, there was constant stressing of good workmanship, and, you know, making sure that the waterproofing was installed correctly. Because, yeah, no one wants ponding water in that valley.
I've got to say, I'm going to give a shout out to Barnes Construction, who were the main contractor on the job, because their site team was fantastic and needed to be, obviously, for all the reasons that Sophie just said there, regards getting that structure covered up quickly, the workmanship of the follow-on trades, particularly, and then, like we said, the site team at Barnes, the coordination, the sequencing that they did meant that it was only exposed for the shortest amount of time. So yeah, that's my shout out for Barnes. They were great.
Yeah, agree.
Totally.
No, thank you for that. And yeah, literally we have run out of time. So a huge thank you to Eleanor, Sophie and Paul. I don't think the three of you, but maybe you will be at Future Build next week. I know we've got a talk on Tuesday lunchtime. I think at 12:30. So if there's anybody in the audience who wants to come and ask more about Homerton Hall, some of maybe your colleagues or maybe yourselves will be there. So come and find us. I think it is on the sustainability or the materials stage. So that's at Future Build next week. And we carry on in 2 weeks' time with the Water Tower, followed by March House and Greyfriars Charterist Centre and the UK Harwood Storage Building, and then a completely different project altogether out of Fenland Black Oak. So then we look at really, really ancient timber and what you potentially can do with that. So as I said, learn from the creators of the Water Tower. That will be on Wednesday, the 15th of March at 1 o'clock. I'm wondering if I've got another slide. So that's the following one. That's in April. I want to go if I just can to. And you can find out more about Homerton College Dining Hall. There's a case study on the Timber Development website. So pop yourselves over to Timber Development UK and just search case studies and you'll find lots of more information. I'd just like to say a huge thank you to Eleanor, Sophie and Paul, and for yourselves in the audience for taking the time to join us. I hope you've learnt a lot. You've understood a little bit more about timber. I mean, for me, I'm going to take away butterflies, buttresses, pubs, coppicing, modelling, carpentry, and what a fantastic, fantastic project. Thank you all.